Okay, we're going to learn how to solve a simple triangle. And we have in front of us again, simple 3, 4, 5 triangle with a pin at A and a roller at C. Shutting my door here. We have points A, B, C. The pin is at A, roller at C. We have an 80 Newton force going to the right at B. So how do we solve this? First thing is, again, remember statics is sort of a detective thing. We have to look for clues. How can we solve this? We know the triangle is not moving because by definition it's not moving. So it has to be held in place by something. So we know that it has to be held in place by the pin at A and the roller at C. So those are providing an external reactive force to the 80 Newton force at B. So one way to solve, as we start this, we will find our external reactive forces. Because it's a pin at A, we know it has a horizontal and vertical force. C only has a vertical force. So those forces have to be keeping the triangle from moving. So now we can use those to figure out, okay, what's the forces on those things first? The horizontal force is easy. There's only A of x against the 80 Newton force, so A of x has to equal 80 newtons. That's not hard. Okay, so our next one down though, we have A of y and C of y. Those are our vertical forces, but we don't know anything about them. So can't use the vertical force yet. But I do know something about my moments. I know that if I were to use A as my pivot, then the horizontal force, the 80 Newton force at B, would be trying to spin the triangle clockwise. So we'd be trying to rotate the triangle clockwise. So I must have a counter torque. That counter torque has to be C of y. The 80 Newton force is 3 units away from B. The C of y is 4 units away. So I can say the 80 Newton times 3 must equal C of y times 4. Do a quick math, solve this, and I can find out that C of y is equal to 60 newtons. Well, now I know one of my verticals. So again, now I can say the sum of my vertical forces have to equal 0. So if I have C of y going 60 newtons up, A of y has to be going 60 newtons down. Okay, so now I got all my external forces accounted for. From there, I can now start solving for the forces on the beams. Again, going to A of y, that's pretty easy. I have a horizontal force, A of x, 80 newtons. The only thing opposing that would be the beam AC. So AC has to equal 80 newtons. AC is in tension. That means the beam is pulling to the right for at A, then it must be, if it's pulling on one side, it's pulling on the other. So at C, it's pulling to the left. And then the beam AB is also relatively easy. I already see I have A of y going down, so AB must be providing the counter force, and A of AB must be pulling up on point A and pulling down on point B. And again, it also has 60 newtons of tension, just like A of y. Okay, now I got those two. Those are simple. What about BC? Well, I know BC is a diagonal force, so I'm going to have to resolve it into its vertical and horizontal components. So let's take a look at that. Hopefully you can see that BC, in order to oppose the 80 Newton force, BC must be pressing into point B, and the force would be going to the left and up. You can see it's sort of diagonal going at northwest. So I know that BC must be pushing. It's in compression. It's pushing into the point, and the horizontal part would be going to the left to oppose the 80 Newton force going to the right, and BCY must be trying to pull up. Okay, so now the question is, if I look at my forces at B in the x direction, BCX must equal 80 newtons. That's what's providing the counterforce. But now I need to figure out, well, how do I figure out what BCX is? Well, I want the horizontal part. So if I looked at the cosine of BC would be 4 over 5, the adjacent over the hypotenuse. So 4/5 of BC equals 80 newtons, and I can do the math real quick. BC must be 100 newtons. Okay, and I can also do a quick sanity check, because I could say BC is also pushing down at point C. And then I could say, well, I only want the vertical part, so that would be 3/5 of BC must equal 60. And again, if you do the math, you're going to see BC comes out to 100 newtons again. So there's our sanity check. Statics is great because you can always check your own answers and make sure it's all good. And now we've resolved all three of those forces. And there we go.